Vega, and this is my math analysis final project. I want to present a great interest of mine that should be everyone else's too. Nature! Trees are the biggest and most important source of life for all organisms and our Earth. They provide us with oxygen, food, materials, they stabilize our soil, and they store carbon. There are currently 3 trillion trees on Earth, the largest being General Sherman, located in Sequoia National Park. It's extremely fortunate. The park is only 2 hours away. Let's go see the tree. Well, there he is, General Sherman. He's huge. He's got to be at least 2,200 years old. So at this rate, he must have been growing at least, at what rate has he been growing? Let's find out. So, finding the rate of growth. Since General Sherman has been along for so many years, 2,200, the best way to see its growth by volume is by graphing it. For plants, a number used to calculate its rate of growth is pretty inaccurate since organisms grow differently, especially plants, depending on their soil, their rainfall, and their geographical location. So General Sherman, at 2,200 years old, is 52,500 cubic feet. And if we divide that by his age, we should get the number of cubic feet per year that it's been growing. However, that's still an inaccurate calculation. So we should try to expand its limit and average it by 220 years to just make it a little bigger. So if we divide 52,500 cubic feet by 10, averaging out to 220 years, we would get 5,250 cubic feet per 220 years. So now all we do is just plot them, and they correspond to each other, so it shouldn't be really hard. And that one. So it should have been a straight line, but in reality it won't be a straight line. So that's exactly how it is from birth to its current age and its current cubic feet measurement. Oh, that's interesting. Take a look at all these trees down here. Since General Sherman is way bigger than them, it's got to take a whole lot of strength, way more, to take them down. So how much strength is needed to take her down in one blow? So how much force is needed to take down General Sherman in one blow? General Sherman's volume makes his tensile strength extremely high. Tensile strength means maximum tension applied on an object that can support prior to its fracture. So it's the maximum force that you can apply to the tree before it cracks. Okay, so to know more or less how much pound force per square inch or megapascals are needed to take down General Sherman, we'd have to find the tensile strength, and we'd use the following formula to find it, which is P equals ST times AS, where P is the tensile load in pounds, so this one is, P means the weight of the tree, ST being the tensile strength, in megapascals, or what is it? Pound force per square inch, and that's what we're trying to find. And AS is the tensile stress area. In inches squared. So this is of General Sherman. And we know our P and our AS because tensile strength is what we're trying to find. So our P is the weight, again, of General Sherman, which is 1,385 tons. And in pounds, it'd be converted to 2,770,000 pounds. And our AS would be our tensile stress area. So for General Sherman, we'd go up around 180 feet, and the tree is 275 feet high. So at 180 feet, its diameter is 13.7. Got a 13.7 diameter. So to convert this feet into inches squared, we'd have to find the area of it. So over here, we see that 13.7 diameter, half of that would be the radius, and half of the diameter would be 6.85. So, and to find the area, it would be pi r squared. So, A, the area, equals pi 6.85 squared. And this equals 147.41 feet squared. And to convert that into inches squared, or square inches, we'd have to convert it, and we get 21,000. So our area is 21,227.04. Okay. Now we'd erase all this. So now that we have our A and our P, we save the value here. A is, so AS actually. AS is 21,227.04, and our P is 2,770,000. Okay. Oh, and this one is squared inches and pounds. So now we can erase all this and complete our formula. So now we can actually plug those two into the formula since we only have one variable left. So now for P, it's 2,000,000 equals ST times 21,227.04. So right here you could just do basic algebra and divide this with both sides. And your ST, already plugged in the calculator, should be 130.49 megapascals. And 130.49 megapascals is equivalent to 18,927 pound force per square inch. So it would take 130.49 megapascals or 18,927 pound force per square inch to knock down General Sherman in one blow. Let's make sure that kind of power never gets to her.